Simplify and state any domain restrictions. Now, regardless of whether I ask you for this or not, you should always look at your restrictions. Because sometimes if you're solving for x, you might come up with a solution that's actually restricted, an x value that you can't then plug back in, an extraneous solution. So we should always look for domain restrictions, and where we do that is after we factor. So I'm going to factor the top and bottom. And I'm going to just write this flat just so we can kind of see what the factors are. So this is x times x times x minus 2 times 2 times x minus 2 times 2 times 2 times 2 times 2 times x all over x times x minus 2 times 2 times 2 times x. So notice in the top factors I have in common, it appears I have an x in every term. So that's something I can factor out. In the bottom it appears I have an x in every term as well. So factoring that out, I have x squared minus 4x minus 32 all over x times x minus 8. Now before you get tempted, some people get tempted to automatically start dividing out. We need to list our restrictions. So the first factor, if x is 0, that would make the bottom 0 no matter what. If I plug in 0 here, it doesn't matter what's there, I will get 0 on the bottom. Likewise, if I plug in, if x minus 8 can't be 0, then x can't be positive 8. Because if I plug in 8, 8 minus 8 is 0. So x cannot be 8 as well. So I have my restrictions, and now I can start to simplify. But I'm not done yet. I'm not done simplifying. There's more simplification to do, because I can try to factor that. So I'm looking for things that multiply to negative 32, that add to negative 4, and I can only do that when my a value is 1, which it is in this case. So, multiply, let's see, so that would be negative 8, positive 4, I believe. So that factors to x minus 8, x plus 4 over x minus 8. How convenient. We can now simplify x minus 8, and we're left with x plus 4, where x cannot be these values. So again, graphing this, it starts at, my y-intercept is 1, 2, 3, 4. It starts there, but when x is 0, there is no value. And the slope is up 1 over 1. So it goes up 1 over 1, down 1 over 1. Except when x is 1, 2, 3, 4, 5, 6, 7, 8, there's a hole there as well. So it looks just like a line with slope 1 and y-intercept 4, except for with 2 holes in it. At 0 and where x is 0 and x is 8.